Hi, folks. I'm Naren. I'm going to be talking a little bit today about interval data types, specifically in the context of Iceberg. So to give an idea of kind of what I'm going to be talking about, I want to start with kind of what an interval is for the folks in the room who kind of aren't aware. Get into some interesting use cases with interval based on some real-world customers that we've seen. And then talk about kind of different interval implementations in a variety of engines. So specifically focusing on the Parquet implementation as well as the SQL one. And I think that'll lead right into kind of what interval types should look like in Iceberg. And we'll definitely have some time for Q&A at the end. So just to start with, what is an interval? So an interval represents a duration of time. I think the key thing to note here is it doesn't have a start or end reference point. It just represents the duration. So for instance, an interval could be something like 3 months, right? And because based on the Gregorian calendar, different months can have different number of days, right? February could have 28 days, 29, depending on whether it's a leap year or not. We consider that to be more of like a flexible type of interval versus an interval like 8 seconds, right? That's a kind of a quantifiable, unit of time that is definable regardless of whether you have a reference point or not. Intervals don't have a reference point, they represent a duration, and you can represent them as a difference between two dates or times. So for instance, on the right here, you have a really simple SQL script where you're inserting kind of interval values, and you can look at kind of the tenure of how long an employee's been at a company. So Erica here has been at whatever company for 14 years and 11 months, and James has only been here for 2 months. I'll get into kind of the exact syntax and why it's built that way a little bit later when I get to kind of the SQL implementation. But for now, I just want to kind of introduce the concept of an interval. Now, what might be a little bit more interesting is, okay, you have this type, it's a duration, why do I care, right? What's the point of using it? So let's take a really simple example here where we're looking at stock price data based on nanoseconds. So let's say I'm a hedge fund doing high frequency trading and I have a bunch of this super expensive stock data. So if I'm looking at Amazon stock price here, right, you can see that the first 4 rows are basically based on prices from yesterday. Obviously, this isn't real data, but ironically, the stock price actually maps pretty well for today. But the fifth row is kind of the stock price today morning, right? So I'm looking at a bunch of stock prices for the first 4 rows and kind of yesterday, and then kind of a big jump to today morning. So you see that the stock price is kind of hovering between 192 and 191 yesterday. I don't know, maybe Trump posted on Truth Social and all of a sudden it's at 205 today. Okay, so what's kind of useful about this data? I have a bunch of timestamps, but what if I want to represent these timestamps as relative differences from each other, right? This is non-uniform data, so think even IoT data or other kind of timestamp related data. I can do something like kind of in the second example here with the query where you're subtracting kind of 2 timestamps from each other based on a lag. So you can see between row 1 and 2, there's a 3 nanosecond difference, row 2 and 3, an 8 nanosecond difference, and then all the way to kind of a 16-hour difference between close of market yesterday and opening of market today. What's useful about doing that is now you can do really interesting things with this interval data, right? I can get around not using an interval data type by doing some complicated casting to and from integers. I can look at number of seconds since 1970, but this is a really simple human readable format where people can use and understand this pretty simply without having to do a lot of conversion back and forth. So I can do things like resampling the data by every 5 nanoseconds. I can interpolate on that data. I can do joins. I can treat this like I would any other primitive data type. And obviously, kind of like I mentioned earlier, this is clearly a fintech example, but obviously in IoT, e-commerce, digital health, there's a lot of different verticals where people care about kind of data and time series formats. So now I'm going to get into kind of, I've talked about, what interval is, what you can use it for, but what are the kind of different implementations that people have used? So here are a bunch of different engines. What I want to really highlight on this slide, and I'll get back to it later, but is the Parquet kind of interval format is very different than the interval format a lot of the other engines use. So SQL Standard, which has been around for forever, most of these sort of engines are compatible more with the SQL Standard variant, and they're not compatible with the Parquet implementation of interval. Arrow is kind of the, make everybody happy, be compatible with everyone. But I'll get back to this a little bit later, and I'll talk a little bit about what the Parquet format looks like and what the SQL Standard format looks like. So in Parquet, you can store an interval as a fixed length byte array. So in Parquet, these intervals are not kind of, primitive types, but they're sort of converted types. So what that means is fixed length byte array is the primitive that you're using for the physical representation, and kind of the concept of interval is really just some extra metadata that you're throwing around on top of that. So you represent it as, 4 bytes for months, 4 bytes for days, 4 bytes for milliseconds. Now, what's important to note here is that because it's a kind of converted type in Parquet, there's actually no min or max statistics that are computed when you define an interval column, which means that there's no default sort order. So it's kind of interesting in that respect, but also that each component of this representation, the months, the days, the milliseconds, is completely independent of the other components. So if I have something like 90 days, that's not equivalent to 3 months, right? Because earlier, like a Gregorian calendar, you have different numbers of days of different months. You don't have equivalence there. And it's also independent of any particular kind of time zone or date. So there's no relative starting point, like I mentioned, for a definition of interval. Now, you contrast this with SQL Standard, right? So you're looking at something that's very different. You have 2 different types entirely. So you have year-month intervals and day-time intervals. Now, year-month intervals are something like 120 years and 3 months, or 100 months, right? And this is kind of more of a human readability thing, but it's not actually a precise period of time, right? If I just told you 2 months, you wouldn't be able to compute that in terms of number of seconds without knowing a relative starting point. So that's where kind of day-time intervals come in. So if you're familiar with kind of the Python ecosystem, day-time intervals would map to Python time delta. If you're familiar with Golang, you would map to kind of a Golang duration. And this is an example where, intervals can be signed. So I can have a daytime interval of, -9 hours, 8 minutes, and 555ths of a second. And in SQL Standard, because you have these 2 categories, and one is kind of more of a precise, and year-month is more flexible type, they're not interoperable. So I can't do kind of add a year-month interval to a daytime interval. I can't do comparisons between the 2. Fundamentally, those operations are sort of disallowed. The other interesting thing about SQL is you have kind of a precision and fractional second precision component to this. So let's take the daytime interval where, the hour precision is 2. What that really means is just 2 digits in the leading field, in this case, hour. And the second precision is 3. So that's 3 kind of trailing digits after the decimal point. The reason SQL Standard does that is because a lot of different databases use optimizations based on the precision and fractional second precision. So if your precision is small enough, you can probably store an interval in kind of a smaller physical type, like a signed 2-byte integer or something like that, kind of under the hood is your physical representation. If your precision is really large, maybe you need more bytes, 4 or 8 or 16 bytes. And that's really kind of the reason around having the precision and the fractional second precision components. So going back to, have these intervals in SQL, 2 different types, not interoperable. You have these interval in Parquet, which kind of mix this year, month, and daytime concept. Let's go back to kind of these implementations in kind of the various engines. So you can see that the Parquet implementation is quite different than what Spark and Trino and Oracle and these other database vendors sort of use. And you might be asking, okay, great, you're talking to me a lot about interval. This is an Iceberg meetup. Why are we, here? And I would love to show you what interval types look like in Iceberg, but unfortunately they don't exist. So that's part of the reason why I wanted to kind of bring this up, as we have a lot of use cases with IoT data, with fintech customers, with e-commerce customers that want to use interval. And they're able to use it in all of these other engines, but it doesn't really make a whole lot of sense that it's not supported in Iceberg yet. So here's sort of my proposal, and nothing here is set in stone. If you have comments or have feedback that you want to give, I've linked the doc here. You can go on the Iceberg and Parquet listserv. This is pretty available. I'd love it if folks could kind of take a look and give advice and feedback. But my proposal is we kind of introduce interval types in really Iceberg and Parquet in a way that's compliant with SQL Standard. So Parquet interval types today, like I said, it's this kind of converted type. It's not actually kind of supported in a first-class way. And so there is precedent for kind of deprecating that version of interval and then introducing kind of 2 separate primitives that will be supported by SQL Standard. So my proposal is kind of for both Iceberg and Parquet, introduce 2 different intervals, year-month interval, day-time interval. For year-months interval, used kind of as a physical representation of 4-byte sign value, representing kind of the lowest precision. So in this case, kind of number of months. For day-time interval, number of nanoseconds. Now, why a 4-byte sign value? Why not 8? Why not 2? Well, first, kind of Spark/Databricks as well as Teradata support a 4-byte sign value under the hood, so less conversions and back and forth between different engines. The other reason is a 4-byte sign value is more than sufficient. I think it represents a range in terms of years of like minus 170 million years to positive 170 million years. If you need, a range that's 1,000x higher than, the duration of human history, I think you're pretty sufficient. And then it corresponds to kind of a Java long. For daytime intervals, there's a lot of variance in terms of what level of second precision different engines support. So Parquet, like I mentioned earlier, supports up to milliseconds. I believe Spark supports up to microseconds. Oracle and Snowflake support up to nanoseconds. But a lot of these kind of use cases that we're seeing, particularly in the IoT and fintech areas, go up to the nanosecond. For fintech, we were talking to one customer and they said the only reason they don't use picosecond is because of physical limitations with sending data over wires. So a 16-byte sign value representing number of nanoseconds, the proposal here, it would correspond to a Java decimal. What this means in Iceberg is you need to create some kind of 16-byte, integer to decimal converter, but I think that's worth the trade-off of being able to support a large number of nanoseconds and dealing with that. So that's kind of the high-level proposal I have, and we've been talking about it a little bit. This is in the doc. Feel free to check it out. And we'd love to hear more feedback about it and kind of changing, this structure and adopting it in both Iceberg and Parquet to support all these kind of different workloads in different verticals. So that's pretty much it for me. I wanted to keep it short and sweet. So thanks everyone for sort of listening to my spiel on time series. And I've been thinking about this a lot, so feel free to ask any questions. Yeah. Yeah, go for it. I don't think we have a mic. Yeah.
Problem. Can you please circle back to the beginning where you presented the use cases?
Yeah. So I'll note that the third text here isn't really standard SQL, right? I just threw that together based on some stuff we're working at Snowflake. I was a little lazy, but in reality, it would be a lot of as-if joins.
But I mean, like maybe something kind of more simplified, but like practical in this sense.
What are you thinking through?
Can you suggest another example? Let me put that here. Something from the top of your head. So I do understand you have market prices and you build basically the interval price pair based on the initial data. Then we can do some transformations on top of it. Just to kind of widen the horizon on why it is important, like in Iceberg and Parquet, can you suggest a different example?
Yeah, sure. So another one that we spent some time looking at is kind of based on IoT data, packet sent, packet received. At a high level, kind of any data that you're looking at that has a non-uniform distribution, think of dates or timestamps, and you're recording that accurately, and you want to be able to do various transformations on it, right?
So basically, if I cannot like present the time span, right, with the like fixed chunks or something, right? So where I can no longer say like our partition or our base statistics, right? Then I can resort to intervals to make it variable length or so.
Yeah, I mean, the concept is just, it's just the data type like any other, right? So if you really wanted to work around it, you could probably create some world where you're doing some complicated casting in various operations, or you're kind of doing a bunch of pre-computed statistics. But yeah, anytime you have kind of aperiodic data from a time series standpoint, interval can be extremely useful for those use cases. Because it's defined as kind of just, you take two dates or two timestamps and you subtract them and you get kind of a duration in between, right? So if you want to kind of sample off of that, or you want to kind of understand, any difference in time, interval's super useful in that context. Does that make sense?
Yeah, I'm just kind of struggling to make this bridge between basically, if I need a time series, I'm going to use a time series DB in that sense, right? So, and if I need like my Iceberg and Parquet, I can use it like almost anything. And the case is that I can do both at the same time.
Yeah. I mean, it's the kind of the macro point is that interval is sort of a standard type in all of these different formats. I can't really think of a rational reason of why not also have it in Iceberg, right? I mean, I understand there's work involved from a technical standpoint to sort of get that in, but setting aside the kind of amount of hours you have to spend, that's kind of the argument, if that makes sense. Any other? Yeah, go for it.
Can you go to the last slide?
Not the thank you, but the one before. Yeah.
So the Java data type, what does decimal data means? It means float.
We think it's big decimal. Yeah. That's a good question. There's more details on the doc itself that walks through kind of exactly our thinking there. But yeah. Yeah.
So basically, intervals, we need like a start timestamp and the end timestamp, right?
Not necessarily. So interval is just a duration, right? So you can calculate one as end timestamp minus start timestamp, but you don't need one to actually define an interval.
So say we have a time interval. So how do we query? It's like within the interval and without the interval, or how does a user to query if he has an interval?
Oh, create one. Yeah. So this is like kind of the second query here. So what I'm doing is I'm selecting kind of the Amazon TS column, and then I'm subtracting kind of that Amazon TS column shifted by 1, right? So lag is just shifting it by 1. So I'm basically just saying column minus column, both columns are timestamped, as that's how I'm creating them. So in this case, I'm using a window function to create it, but you can also do something much simpler, like say, select A minus B, where both A and B are timestamp columns as interval from whatever table.
So say I have an interval data type, so is there like specific indexing for the interval?
I mean, as we define it in kind of as Iceberg or Parquet, you're really looking at just the kind of the physical format of it. In terms of how different engines or databases implement it, yeah, some can have optimizations around kind of the indexing. You can compute kind of min and max and do various operations on that. Did that answer your question? Or okay.
So it's like a engine specific.
It can be. I mean, different engines can choose to optimize in different ways, but fundamentally, it's going to be indexed the same way as it would kind of any other data type, because you have a definable kind of ordering to it, right? So something like 3 nanoseconds is going to be higher than 0 nanosecond interval, right? So you have a fundamental ordering you can rely on for indexes, and that's kind of unlike the archaic sort of interval today, where there actually isn't a min and max defined, so you don't have kind of sort metadata that. Any other questions? Okay. I think the gentleman who was supposed to, or I guess we're on break now, so I don't think I need to hand it off to anybody. But yeah, thanks everyone.